Hello dear students, in this video we will learn the determination of apparent depth. Okay, so let's start this video lecture. So to understand the determination of apparent depth, we will take two cases. So there is our first case. So in our first case I consider that when object is in denser medium. Okay, so what happened, there is an object, let object is a fish. So there is a fish and this fish is at a position A. Okay, this fish is at a position A. If a person wants to see this object, okay, if a person wants to see this fish, then the light ray must reach to his eye of this person. Okay, so let's see this diagram. There is a light ray, so this is our incident ray. Okay, so this light ray goes and incident at the point of incidence O. Okay, so this is a point of incidence and NN dash is a normal at the point of incidence. Okay, and this I is the incident angle. Okay, now because this is incident angle, this is also a I. Okay, now because this light ray is going from denser medium to rarer medium, so what happened, this light ray bends away from the normal. This light ray bends away from the normal. Okay, and this R is the refracted angle which a refracted ray is making with the normal. Now if you extend this refracted ray in a backward direction, if I extend it in a backward direction, this line will cut this vertical line at a point B. Okay, so what happened when a person see this fish, he see this fish at a position B, not at a position A. Why? Because of refraction. Okay, so this A is the actual position of a fish and B is the apparent position of a fish. Okay, and A to C is the actual depth of a fish and B to C is a apparent depth of a fish. Okay, I hope you understand this, that a person, when a person see this fish, he will see this fish at this apparent position B. Okay, now let's see a simple calculation, that AC is a apparent, AC is a real depth of object, BC is a apparent depth of object. Now when you apply a Snell's law, a light ray is going from water to air, so we will write the refractive index of air with respect to water. So sin I by sin R is equal to mu A W. Okay, refractive index of air with respect to water. Now we have a triangle OAC. Let's see here, there is a triangle OAC, this OAC. So in this triangle, if I determine the value of tan I, so that tan I is equal to perpendicular by base, means OC divided by AC. Okay, so apply this in triangle OAC, perpendicular by base, OC divided by AC. Now if I consider I is a very small angle, so there is a small mathematics that when we consider a small angle, very small angle, then in case of sine we put the value of angle. Okay, and in case of cos we put the smallest value, which is 0. Okay, so that cos 0 becomes 1 and sin I is there. So when I is very small, we can consider tan I as a sin I. Okay, so sin I is equal to OC upon AC. Similarly, there is a triangle OBC. So in this triangle OBC, as you can see, OBC, when I determine the value of tan R, so that tan R will be equal to perpendicular by base, means OC divided by BC. So apply this here, OC divided by BC. Again consider R is a very small angle, so that tan R will be equal to sin R. So I will get sin R is equal to OC upon BC. Now we have equation 1, 2 and 3. So by these three equations we will get sin I by sin R is equal to mu A W and it is equal to BC by AC. Why? Because when you take sin I by sin R, this value of OC will cancel out each other. Okay, so you will get this value mu A W is equal to mu A by mu W. Mu A is the refractive index of air. So refractive index of air is 1, refractive index of water is mu. So I will get this relation. So this is a very important relation whenever we solve a problem in which we need to determine the apparent depth and the object is in a denser medium. we apply this formula. Okay, so always remember this formula. Whenever our object is in a denser medium, we apply this formula. Okay, now let's move to a second case. So in our second case, what is happening? Our object which we want to see is in a rarer medium. Okay, so this is our object A. So this object is in a rarer medium, and a person who wants to see this object is in a denser medium. Okay, that person is in a water. It is a case occur when a person is in a swimming pool within a water. Okay, and he wants to see an object which is outside in air. So what happens? There is an incident ray. This incident ray travels. Okay, it incidents on that point of incidence. There is a normal n and dash, so this angle is incidence angle. Okay, now because this light ray is traveling from rarer medium to denser medium, so that it bends towards a normal. So this is our refracted ray. Now this refracted ray will reach a eye of a person. Okay, now this refracted ray is making an angle r with a normal. Okay, so this r is the refracted angle. Now if I extend this line in a backward direction, this line will cut this vertical line at a point B. Okay, so what it implies? It shows that when a person see this object at point A, he will see this object at its apparent position, and its apparent position is B. Okay, so now BC is called apparent depth. Okay, what is BC? Is the apparent depth of a object, and AC is the actual depth of the object. Okay, so let's see a calculation. So in this calculation we have AC is the real depth of object, BC is the apparent depth of object. Okay, so again a light ray is traveling from air to water, so I write refractive index of water with respect to air, and it is equal to sin I by sin R. So again I am taking a triangle OAC. So as you can see in OAC, here it is OAC, in this triangle OAC, when I determine tan I, so this tan I is equal to perpendicular by base. So perpendicular is OC and base is AC. Okay, so apply this formula. So tan I is equal to perpendicular by base, so it is equal to OC by AC. Again I consider I is a very small angle. Now because I is a very small angle, so that tan I is equal to sin I. So I will get sin I is equal to OC upon AC. Okay, now take a triangle OBC. So in triangle OBC, when I determine tan R, this tan R is equal to perpendicular by base. So perpendicular is OC and base is BC. OC divided by BC. So apply this formula, OC divided by BC. Now again R is a very small angle, so I take tan R is equal to sin R. So by this I will get sin R is equal to OC by BC. Now using equation 1, 2 and 3, in this case I will get sin I by sin R. Sin I by sin R is equal to mu AW. Mu WA, refracted index of water with respect to air. Okay, now here I will get it is equal to BC divided by AC. Now what is BC? BC is the apparent depth, AC is the real depth or actual depth of an object, and we consider refractive index of water is mu and refractive index of air is 1. So I will get this formula, mu is equal to apparent depth divided by real depth. Okay, so again this is a very important formula. So whenever a question comes when a person who is seeing an object is in a denser medium, or generally that person is in a water and he wants to see an object which is in air, so in that case we apply this formula. So these are the two formulas you can use to determine the apparent depth of a object. So I hope you understand both the formulas. And now for the competitive examination, you just remember both the formulas and both the cases, and by the help of these two formulas you can solve all the problems based on apparent depth. Okay, thank you for watching this video.